Have you ever found yourself smoothly breezing through a daily routine, maybe typing away on your keyboard or navigating your kitchen, only to completely freeze up when one tiny little thing gets moved? Even in a highly controlled laboratory setting, when you watch a volunteer confidently work through a familiar task, a simple shift in the layout causes immediate, visible hesitation. Well, today, we're figuring out exactly why that happens. Welcome to this explainer on the psychology of habit interference, demonstrated right here through a classic card sorting experiment. Here is a quick look at our laboratory syllabus for today. First, we'll cover the concept. Second, the lab setup. Third, establishing the habit. Fourth, testing interference. And finally, we'll wrap up with the results and conclusion. Let's jump in.
All right, section 1, the concept, and understanding the transfer of learning. What you're seeing defined here is known as habit interference, or as it's often called, negative transfer. You see, through repeated practice, our brains create these incredibly strong, super-efficient neural pathways to reduce our cognitive load. We learn where things are, and our bodies just react automatically. It's the whole reason you don't have to consciously think about how to tie your shoes anymore. But in this experiment, we want to know, does a suddenly changed arrangement cause that deeply ingrained habit to actually block or slow down new learning? Think about switching from a Mac to a Windows keyboard. Your fingers totally know what to do, but that old habit suddenly becomes a massive roadblock. Moving right along to section 2, lab setup, preparing the experiment. The core aim of our practical demonstration today is to strictly observe this negative transfer of learning. And we're going to do it using a really standardized instrument, the card sorting tray. Now, the reason this specific tool is basically the gold standard in psychology labs is because it forces the brain to rely on spatial mapping. It's a beautifully simple but highly effective way to measure exactly how quickly the human brain adapts, or, fails to adapt, to brand new spatial rules. The setup for this is incredibly precise. On the lab table, we use a central card sorting tray, featuring two very distinct layouts, Section A and Section B. Within those sections are 4 target compartments labeled with a triangle, a circle, a square, and a diamond. We've also got a deck of exactly 40 shuffled cards, 10 of each shape. And of course, the absolute most critical tools for any psychological observer, a trusty stopwatch and a formal recording sheet to meticulously track both time and errors. So, let's talk variables. The independent variable, the thing that we as the experimenters are actually manipulating, is the arrangement of those card compartments, basically swapping Section A for Section B. Our dependent variable, the reaction we're actively measuring, is primarily the time it takes our female volunteer to complete the sorting task alongside the exact number of errors she makes. Everything we're setting up here leads directly to testing this formal hypothesis. Habit formation negatively influences new learning. We're predicting that our participants' thoroughly ingrained routine isn't going to help her when the rules change. In fact, we think it's going to actively slow her down and trip her up. Now, to ensure absolute experimental integrity, the faculty instructor makes sure the volunteer is seated correctly and strictly follows these steps for every single trial. The 40 cards are thoroughly shuffled completely out of her view. They are presented face down. A clear start signal is given, the stopwatch clicks, and she has to sort every single card into its corresponding compartment as fast as humanly possible. This incredibly strict adherence to procedure is what successfully isolates our variables. Okay, Section 3, establishing the habit. Trials 1 to 5. Obviously, to test if a habit interferes with something, we first have to actually build that habit. This happens over the course of our first 5 trials exclusively using the Section A arrangement. As we start trial 1, it's totally normal to see some early hesitation as the volunteer visually searches around for the triangle or the diamond. But as we progress all the way through to trial 5, that hesitation just melts away, replaced by a practiced, almost completely automatic rhythm. 5. That is the exact number of consecutive trials it takes in our setup to establish a rock-solid baseline. Across these 5 runs, you can literally watch her completion times decrease. This steady improvement perfectly demonstrates that a really strong physical and mental habit has been formed. Her brain's spatial map is fully dialed in, and she knows exactly where every single shape belongs in Section A. Which brings us to Section 4, testing interference. The crucial trial 6. All right, the habit is set, the muscle memory is entirely locked in. But right before trial 6 begins, the instructor quietly switches the tray from the highly familiar Section A over to Section B. This completely changes the physical location of the triangle, the circle, the square, and the diamond. The cards are exactly the same, the overall goal hasn't changed, but the spatial rules, they've just been entirely rewritten.
The moment Trial 6 begins, we instantly have our answer. You can see it. Her ingrained habit violently clashes with the new layout. She moves to place a triangle where it used to be, realizes the compartment now holds a circle, pulls her hand back, and frantically searches for the new target. This right here is the ultimate visual representation of cognitive interference. Her brain is sending rapid-fire signals based on a map that is completely outdated.
Let's move to Section 5, Results and Conclusion. Time to analyze the data. Before we crunch the numbers, you have to understand how strictly errors are recorded in this practical. Any incorrect placement is officially an error. No exceptions. Even if our volunteer immediately catches her own mistake and moves the card to the right slot, that original slip-up, which was driven by her old habit, is permanently tallied against her. Looking directly at the recording sheet, we're tracking the time and errors across all 6 of these trials. But the critical comparison that's actually going to answer our hypothesis boils down to simply comparing the data logged in row 5, the absolute peak of her habit formation, versus the data in row 6, the exact moment of disruption. We interpret these laboratory results using a very strict logical formula. If trial 6 takes longer than trial 5, we have definitively proven negative transfer. If somehow changing the board miraculously made the process faster, which, let's be honest, is highly unlikely here, that would be positive transfer. And if the times were identical, we'd simply record 0 transfer. When we look at the results, the pattern is just undeniable. The smooth speed and the constant reduction in time across those first 5 trials prove beyond a doubt that the habit existed. Therefore, that sudden, sharp spike in time and errors during trial 6, that is a direct result of the changed arrangement. Neurologically speaking, her brain is being forced to unlearn and relearn simultaneously. The existing neural pathways dedicated to Section A are actively misfiring in the context of Section B, causing a massive delay as her brain struggles to override its own efficiency. But of course, a thorough academic discussion has to remain completely objective. We always have to acknowledge that other factors could be influencing these recorded times. Did experimental fatigue set in by the time we hit trial 6? Were there any subtle lab distractions? Was the shuffling truly randomized between every single run? These are the real-world variables researchers always have to control for when measuring human performance. But factoring all of that in, we arrive at our concise laboratory conclusion. Based on the clearly recorded increase in time and errors during the 6th trial, we officially accept the hypothesis. Habit formation absolutely negatively influenced the volunteer's ability to learn the new spatial layout. It's honestly a fascinating look at how our brains prioritize efficiency, sometimes completely to our own detriment. As we wrap up this explainer, it really leaves you wondering, whether it's a completely new software update on your phone, a randomly rearranged grocery store aisle, or a forced password change at work, just how much of your own daily frustration is simply negative transfer in action. Thanks for joining me in the lab today, and keep questioning the habits that guide your world.